Let's look at a different question, though. How many red cars have passed a certain point on a highway within a certain time window, time period? The photo here looks like a Seattle highway, which is more like a parking lot, but that's not the point. So assume that cars are actually moving, right? Moving fast on a highway. So if we try to keep that analogy with a relational database, you see it's not really working anymore because for a database, data needs to be persistent and static. So I would have to take all the cars, pull them over, park them in a lot, and then keep them there for a certain period of time and count them there as I did before, and then release them back to the highway. Obviously, this is not really a good solution here. It's not really feeding that scenario. So we realized different kinds of questions require different ways of answering them. Specifically in that case, answering the second question with a stream processing engine drastically simplifies that use case by just standing by the freeway and counting the red cars as they pass by without even interfering with the flow of cars. And at some point, writing down an answer and deliver the answer. So that's kind of the streaming data paradigm in a nutshell for us, asking questions about data that is in flight without having to persist the data. So that's one of the core design principles of the StreamInsight products, on-premise as well as in the cloud. There's no difference here. Data is not stored, and processes are not transactional. Queries are not transactional. Data is kept in memory as long as necessary, defined by my queries, like windows in time. So the engine knows how long to keep the data in memory, and then the data is discarded. The result is produced, the result is passed on to the consumer, and then the data is discarded. That's not needed anymore. So there is no persistence, which enables the engine to be really fast. And not only fast, but also event-driven. And that's one of the, I usually find that even more important than performance is being able to be event-driven, to react on inputs as it is happening, and not based on some reporting frequency or workarounds, I would say, quote-unquote workarounds like triggers in a database. It is really, the engine is really processing the data and incrementally updating the results as soon as new input data comes in. So my output is always as current as it can be, with a latency of what we are targeting within the millisecond area. So that's kind of the paradigm, which is really very different from classical databases because the problems are very different. Few scenarios for StreamInsight, and again, this goes back to the on-premise product of StreamInsight, and some of these still apply to the cloud. I don't want to go through all of them. Maybe just pick a few examples. Manufacturing, specifically in batch processing use cases, there is this concept of the golden batch. A golden batch is a product batch with very high quality. Once such a golden batch is determined, the goal is naturally to recreate production parameters as they occurred during the golden batch as closely as possible. Provided that these parameters can be measured and also adjusted in real time, a complex event processing system like StreamInsight can be used to create that real-time feedback loop with low latency analytics over the incoming sensor data. As you can imagine, there it's not really desirable to store all the measurements, all the sensor readings first in a database and then query the database, because with the increasing amounts of data, with increasing throughput, the I/O costs just become a big challenge. So I want to process the data as it is in flight. Another scenario is the streaming analytics over user clicks on a web property, and I mentioned that briefly before. I want to talk about it again because this is another real-world scenario that actually has been implemented in the Microsoft online property platform, Ad Center, providing ad placement services on the Microsoft sites and online properties like MSN and Hotmail. So that was a very early engagement within Microsoft using StreamInsight, where interactions of users with a respective web page, like clicks or search keywords, are streamed into a StreamInsight deployment in real time without the indirection of storage. Within the StreamInsight framework, the click streams then run through different analytics or standing queries, as we call them, For instance, a market segmentation query determines a user to be a promising target for ads for a certain market segment. And then these ads are served within a few seconds while the user is browsing the site. Before StreamInsight was used for this use case, the process had a turnaround time of several hours. So it only made sense for ads about big consumer items where the decision process takes longer. Makes sense for people intending to buy a car, but waiting a few hours with an ad for, say, a meal delivery, a pizza delivery is, of course, not practicable. So reducing that from hours to seconds opened up a whole new set of use cases. How does StreamInsight look like? Well, again, we usually start with event sources producing event data. Proprietary event data could come from web servers, devices, sensors, could also be replayed from event stores and databases, persisted time series data that needs to be replayed to be analyzed again, or things like stock tickers and news feeds. All of these data sources stream their data into a StreamInsight server, assuming a StreamInsight application and use case. And they do that via what we call simply event sources. Those are pieces of software that the user has defined, either through .NET interfaces like IEnumerables or IObservables that can be turned into a StreamInsight event source, or through our traditional adapter model, which is an API, part of the StreamInsight SDK, to wrap my data sources into stream sources for StreamInsight. So from there on, the streams become kind of a canonical stream format, and they can then go into the queries, the standing queries, the computations that the user wants to run against the streams. I can compose queries one on top of the other. I can build more complex use cases based on simple subqueries. And eventually the results go into the counterparts of the sources, which are the event sinks. Again, those are user-provided assemblies, can be based on .NET sequences, can, for instance, just be an IObserver, in that case, the counterpart to the IObservable. And from there on, I can just dequeue the events and then consume them. And consuming events, that again is up to the use case and up to the developer. Could be to store them in a database after I have sufficiently reduced the data rate using an aggregation query. I can now store them, display them on a dashboard, like in the example with the streaming video, telemetry analytics, or stream them over the network to some other consumer. All of this is based on the StreamInsight library, basically the SDK, the platform that you get if you install StreamInsight. And I'm now referring to the on-premise products, where the StreamInsight server runs on my machine in my process. And all of this is it's a developer experience, it's a developer platform. So what's important to point out here is StreamInsight as a product is not an end-to-end solution with a fully baked UI. It's a developer platform that needs to be integrated into a bigger picture using other pieces like event sources, event sinks, and the UI. So it is heavily based on .NET developer experiences like Visual Studio. We also provide a LinkPad plugin so that you can use the lightweight LinkPad interface to quickly test, learn, try out, prototype StreamInsight queries against simulated data sources and things. How does a query look like? I've talked about queries a lot. Now, how would I write such a query? What you see here is a very simple example of an aggregation over a time window. In this case, I am creating a window that is 10 seconds long, and within this window, every 10 seconds, I'm computing the average of a certain field in my incoming event stream. So naturally, what this query would produce, as soon as it is up and running and receiving data, every 10 seconds, it will produce an output of one value representing the average of all the values within the incoming window, which could have been 10 or 10,000. It's producing one output for each window. And so this is LINQ. For those of you who know .NET or even just SQL, that's a very familiar way of specifying analytics and computations, extended by the StreamInsight specific interfaces like tumbling window. That's something that the StreamInsight SDK adds to the Link developer experience.